Today our goal is to rewrite exponential expressions to be able to see the patterns and structures and get really good at using exponents. So first we're going to write using base 2, rewrite. So 8 is really equivalent to 2 times 2 times 2. So that would be 2 to the third power. 4 is equivalent to 2 times 2, so that's 2 to the second power. You might not know yet what is 32 as base 2, but you might think, well, 2 times 2 is 4, times 2 is 8, times another 2 is 16, times another 2 is 32. So it took us 5 times, 2 to the 5th. That's all we need to do for this problem, and then we are going to start to notice a pattern. How do we get to that 5 using a 3 and a 2, and keep in mind that these are being multiplied. So we could expand this out. We could have 2 times 2 times 2, that's the first 3, and then we have 2 more. There we see we have 2 to the 5th power. Again, we're just noticing patterns today so that we can be better at using properties of exponents. In number 2, we're looking at 16 divided by 8. How can we write 16 as a power of 2? 2 to the 4th power. And we just said that 8 is 2 to the 3rd. We know that 16 divided by 8 gives us our answer of 2. We already know that. But let's take a look at what's happening to the exponents. 2 to the 4th over 2 to the 3rd. We're left with 2 to the 1st power. You can also write that out, 2 times 2 times 2 times 2. That's called expanding. We can cross off a 2 from top and bottom, and when we're doing that, we're essentially dividing top and bottom by the same thing, and you can do that. It keeps the expression equivalent. We're dividing top and bottom by 2 3 times until we're left with just 2, one of those 2's left, and one of those 2's is another way of thinking of the exponent is 1. In this one, we have another division problem. It's the same numbers, but this time flipped. So this time we have 2 to the 3rd on top and 2 to the 4th on the bottom, and we're left with a half. So again, we can expand it out to see what happens. And cancel. And we're left with nothing on top, but that nothing is really times a 1. You can always times anything by a 1. And so we have a 1 over 2, or a half. What did we do to the exponents here? How did we get from between a 3 and a 4, and then we're left with just a half? There's no exponent written here. So think about what exponent you think this should be. In the last problem, we know 8 divided by 8 is 1. Let's write it out. If we have 2 to the 3rd over 2 to the 3rd, we can cancel everything, right? And then we can also see that there was that unwritten 1, so it's like a 1 over 1, and that's 1. And then I forgot to write the actual exponent, so 2 to the 3rd over 2 to the 3rd. There's no 2 left anymore. It's just a 1. So what happened? What is the exponent on the 2? What happened between the 3 and the 3 that now there's no 2 left? Let's think about this further by looking at the pattern that happens in a list of powers of 2. First, let's look at positive exponents. 2 to the 1st power is 1. Sorry, 2 to the 1st power is 2. 2 to the 2nd power is 4, and 2 to the 3rd power is 8. What's happening from line to line right here is that we're just multiplying by 2. That's what exponents do. So what we need to think about now is what's happening if we're going backwards. So just thinking in a different way. From 4 to 8, we multiplied by 2. So how would we get back up from 8 to 4? What are we really doing? We're dividing by 2. Let's do it again, right? This is the pattern that we're going to see, because from 4 to 2, we're dividing by 2. And as we're dividing, the exponent is going down. 3, 2, 1. What comes next? 2 to the 0. Well, if we kept our pattern going, we would just divide by 2. So what do we get from 2 and then divide by 2? We're looking at 2 over 2, and that is 1. That is the answer that should go in that spot. So 2 to the 0 power is 1. I just want to take that back up to some of the problems that we just talked about. 2 to the 0 power. I see over here we had some exponents. 2 to the third, 2 to the third. Those all canceled out. And what we were really left with was times 2 to the 0. It just wasn't written there. Let's keep moving back on up. So if we divide by 2 again, I'll take it out on this side now. So divide by 2 to go back up. 1 divided by 2 is a half. So 2 to the negative first power is a half. Whenever you see a negative exponent, it means basically like a fraction. The reciprocal, 1 over that base. Up here we had a half. So what would have happened is that 3 and the 4 together, using a pattern you may see, would give us a negative exponent, or the base is only on the bottom now, and that's a half. One more time, or 2 more times, let's do this pattern. So from a half and then dividing by 2 again. By the way, dividing by 2 is the same as just multiplying by a half. Dividing something in 2 pieces is the same as taking a half of it. And when we do that, we can multiply across. 1 times 1 is 1. 2 times 2 is 4. So this is 1/4. And if we do it one more time and divide by 2 again, we have 1/4 again times another half. 1 on the top, and 4 times 2 on the bottom is 1/8. So this number is getting smaller and smaller. So think of negative exponents as becoming a smaller and smaller fraction.